Sustainability and global decarbonization is a huge topic throughout the world. But how can we, as the engineering community, help facilitate these goals? What if we start big with the buildings around us? Hi, I'm Amelia Dalton, host of Chalk Talk. Did you know that buildings are responsible for 40% of global energy consumption and 33% of greenhouse gas emissions? One way we can help both modernize and increase sustainability in our buildings is by adding 10 base T1L to our building controllers. In this episode of Chalk Talk, Salem Garbi from Analog Devices and I chat about how we can enable sustainable enterprises with Ethernet-connected building controllers. We examine the 10 base T1L flexible design solutions that Analog Devices offers, how existing building infrastructure can take advantage of 10 base T1L, and how you can get started on your next sustainable enterprise journey. Hi, Salem. Thank you so much for joining me.
Hi, Amelia. It's so nice to meet you finally. Well, I've been a fan of your show for a while, and I'm really happy to take today about sustainable enterprises.
Excellent. Well, thank you so much. So we are talking today about sustainable enterprises of the future. So, Salem, what does that mean to you?
Okay, so let's understand first the meaning. So sustainable enterprises are enterprises that service the needs of current generation without compromising the needs of future generation. I don't think a lot of people are familiar with this, but buildings are responsible for a third of the global energy consumption. So looking to the economical and environmental challenges, it's very obvious, especially now that the intelligent building management system space is at the center of controlling the building energy users. As you can see here, the building management system market is expected to grow because of this need to conserve energy and reduce waste. This growth is expected a CAGR of 10% year by year until 2030, and is driven actually by the demand to optimize the intelligent building management system, safety, efficiency, and security, which will lead eventually to a more sustainable future.
Excellent. Now, Salem, have you seen much change in technology in this area? Buildings and upgrades tend to be slow adopters. Do you think that's fair to say?
Yes, it's too fair to say that when you build a building, you are making an investment that you hope to last 25 to 30 years. So once the system has been committed to it, it's tough to get the owners to upgrade it if they don't have the return on investment they hoped for. This is called a sunken cost fallacy, as the owners have sunken a cost into the older, outdated system that could be costing them more in energy, time, and money. By upgrading today to a newer system, building owners are able to save even more time and money over the rest of the 25 to 30 years life cycle. Let's understand more that by going through the history of direct digital controllers. In the past, buildings were passive and unconnected. Early controllers were primitive and pneumatic. The shift to analog controllers brought better precision control and easier management by using central monitoring. As you can see here, by the 1979, the invention of the direct digital controller opened the door for a new area of building automation. At that time, the primary focus here was on energy optimization of building management system, but until the 1990s, standardization and open protocols such as BACnet and KNX followed soon after. These new protocols enabled buildings controllers to communicate with each other using centralized control commands and visual data that can be analyzed to provide better decision making. Starting from 2007, the age of the smartphone, apps, and cloud computing started enabling digitization of the buildings with more connected devices, which led to more data making. By the move of IoT in 2016, the building management system is now integrated into an IoT network focusing on efficiency and system performance. This helped making buildings fully connected to people and enhanced the occupants' experience. It's very obvious today that AI and machine learning are becoming the main focus of smart buildings. Future buildings will be able now to anticipate maintenance and repair in order to optimize performance, efficiency, increase productivity, and even increase the revenue of an enterprise.
So, Salem, cloud and enterprise connectivity has changed the game for intelligent buildings. Would you agree?
Yes, I agree, and here is why. Let's imagine the building as the human body. The cloud would be the brain. This is where the bulk of the computing and processing gets executed. The building management system would be the nervous system, and it connects the brain to the limbs and transports data to tell your body what to do. Without the brain or the central nervous system, we have no intelligence, and our building is just an efficient shell. The added benefit of cloud computing is that the building management system data can be accessed from one central location via the cloud from anywhere you want. As you can see here, the building management system is composed of 4 levels. First, you have the edge device level or end nodes. It contains actuators, valves, analog and digital sensors. Actually, we can consider this level as the bridge between the analog and digital worlds. And it's the most connected with the occupants of buildings. And that makes sense as all feedback to the building management system starts at this level. Second, we have the field devices level. This level is made up of unitary controllers, room controllers, gateways, and I/O models. It's considered as the bridge between the edge and the control level. Next is the automation or control level. This level can be considered as the brain of the building management system. It contains the principal DDC and the building management system routers. The principal DDC processes the inputs from the field devices and decide whether to take an action to exchange one of the building surfaces. On top of all of these, we find the enterprise level, which is considered as the management level of the building management system, and it contains actually the cloud infrastructure. This level also displays all the information gathered by the building management system in a graphical user interface. In some systems, the management level can also be configured to send data via text or emails for notification alerts. Okay, after understanding the building management system architecture, you can notice as shown in this diagram here that existing systems needs gateways to connect edge sensors to the cloud. 10BASE-T1L removes the needs of complex power-hungry gateways and enables seamless edge-to-cloud connectivity. This new Ethernet protocol reduces actually the cost, the complexity of installation by achieving longer reach with a better real-time control of field devices and edge nodes. In order for you to achieve a flexible system design, ADI offers 3 10BASE-T1L solutions, compliant with the relevant IEEE I02.3CG standard. Our first product is the IDIN 1100, 10BASE-T1L5, which supports MII, RMII, and RGMII MAC interface. The second product is the IDIN 1110. It's a 10BASE-T1L transceiver. It has an integrated MAC interface and enables direct connectivity with any host via SPI interface. Finally, we have the IDIN 2111, a 2-port 10BASE-T1L Ethernet switch that has an integrated 10BASE-T1L5, and it also supports SPI interface. These 3 solutions allow systems engineers to reduce network complexity and offer seamless edge-to-cloud connectivity by enabling centralized real-time control of edge devices.
Okay, so Salim, can we use existing building infrastructure, or is a complete building overhaul needed?
Well, yes, we can use the existing building infrastructure, but at the same time, we can use 10BASE-T1L. Actually, 10BASE-T1L, as the name indicates in the standard, is an Ethernet-based protocol that can work for a long reach for up to 1 kilometer over a common single twisted pair of cables. And that can be ideal for retrofitting, as the old cabling infrastructure can be reused in some use cases. If we look to this diagram, 10BASE-T1L is defined in layer 1, which is the physical layer. The physical layer supports common Ethernet protocols such as BACnet, KNX, and LAN, which are commonly used in existing building management systems. So upgrading to 10BASE-T1L is straightforward. Compared to legacy protocol, 10BASE-T1L uses 10 megabits per second data rate over long distances with a virtually unlimited number of edge nodes. It also supports different topologies, including point-to-point, daisy chain, and ring. 10BASE-T1L can also support power over a single twisted pair of cable, which can go up to 52 watts for a compliant 1 kilometer cable in a point-to-point topology. Here we can see an example of an existing direct digital controller block diagram, also called building controller. So basically, a DDC is a system that can read and write analog or digital signals from various devices or field sensors and actuators. It's able also to support different protocols with the capability to send information to another controller or DDC. We need also to mention another key element of a DDC, which is system monitoring and fault detection. We will explain more in the next minute how 10BASE-T1L can provide some of these functionalities and features. As you can see here, adding 10BASE-T1L to your existing DDC enables seamless Ethernet connectivity. In this diagram, you can see how 10BASE-T1L products can be incorporated into the building and room controllers to communicate as many room or building controllers as necessary, either in a ring or line topology.
So, Salim, with making the building smarter, is it harder for people to manage this infrastructure?
Well, the whole point of connected and automated buildings is to make the system easier to interact with, easier to understand what is going on, and ultimately easier to manage. To implement a scalable solution, you need to automate not only the connectivity, but also the fault detection and diagnostic, which is a piece of the puzzle as well. What fault in this system, we want to pinpoint exactly where they can occur in order to send the feedback needed to fix that issue. This is very handy when you have a large geographical site or campus of buildings. 10BASE-T1L products have diagnostic features that includes and enables actually DDC to detect changes on the connector contact resistor, the termination circuitry, the cable itself, and even to track cable degradation over time. When we have a cable with a possible length of 1 kilometer and multiple nodes apart, this can be a very handy tool to pinpoint where the fault has occurred. Other solution of diagnostic with 10BASE-T1L includes time domain reflectometry, TDR, which can be used to measure the cable length of a system and provide information about occurrence and location of fault. Signal quality indicator, SQI, which uses also the minimum square error to define the signal quality in a noisy environment. There are also loopback mode that can be tested on the digital and analog data path. And last but not least, the PMA test mode that are defined by the IEEE 10BASE-T1L specification. Analog devices products support all of these test modes outlined in the standard that are necessary for assessing the PHY compliance.
Salim, this has been a lot for my listeners. What would your 3 takeaways be?
Is the first takeaway I'd hope everyone acknowledges is the need to change our thinking towards sustainability. By adding 10BASE-T1L to your building controllers, you remove the need of complex power-hungry gateways, and you enhance your building management system by providing real-time control of sensors and actuators. Doing more with less is the ethos, and what better place to start where we live and work in our buildings. The second takeaway is that by using 10BASE-T1L building controllers, we are able actually to achieve longer reach with virtually unlimited number of edge devices, depending on your network performance and requirements. The last takeaway is that 10BASE-T1L enabled building controllers are able to monitor your network failure and define cable issues in real time using fault detection and cable diagnostic features.
Excellent. Well, Salim, this was super cool. If someone wants to get their smart building journey underway today, where would you advise they start?
Well, everything you need to know about the sustainable enterprises of the future can be found at our website, analog.com/intelligent buildings. On our interactive website, you can find solutions for building controllers, security and surveillance, even energy management, and so much more. Thank you so much for your time today. And for the audience, I hope we will interact at some point in the future.
Excellent. Well, Salim, thank you so much for joining me. I really appreciate this.
Thank you so much.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Analog Devices. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.